Good afternoon. My name is Ishara. I am here presenting on the behalf of my team the project which we have done in our digital image processing. The topic of my project is normalized cross correlation based fast template matching through partial elimination. Here we have made three functions and one main file, and these are the function files, that is partial cross correlation, normalized cross correlation, that is represented here by n cross co, and this is plotworks, which is just plotting or making a square around that template that we have found in that image. Let's understand first of all what is normalized cross correlation. N cross co, this is n cross co function. First line is just a Matlab syntax for implementing or writing a function. First of all, there are two input images that I am giving to this function. First is image1 and second is image2. For each image, I am checking that is this image a RGB image or a gray image. For that, I am using that size function, in which I am giving input of each image1 and then image2, and checking its third dimension for each of them. And if the third dimension is 3 means first is our G and B. If it is 3 equals, then that means the image is a RGB image. So from RGB image, first of all I have to convert it to gray image. So I have written this function RGB to gray. This will convert image1 to image1 which is RGB to gray which is also image1. Now secondly my work is first classify that which image is target image and which image is template image, as I have just given the input without representing that which is target and which is template. So if the size of image is greater than the other size, let image 1 is greater than image 2, then image 1 is for sure a target image, because the target image which is containing many information that has more pixels as compared to template which contains some specific pattern of the target image. So the image which is of greater size is represented as target image, and the image which is of less size is represented as template image. So this is the condition if and else that I have written to classify the image as target and the image as template. Now, third step is I have to store the size of each of the image. First is target and the second is template. That I have used size function and represent its size as row and column. R1 for target image rows and C1 for target image columns. And similarly R2 for template image rows and C2 for template image columns. Now, the function we are operating to make this work is the algorithm we are using is normalized cross correlation. In normalized cross correlation function, we uses means for image or the function, we subtract its mean value from each of the value and do summation over the whole image. So for that I have to calculate the mean. So first of all I am calculating the mean of template image, and so the mean of the template image is calculated by this operation, mean of template image. This first mean is calculating mean over columns, and then this last one mean is calculating mean over calculated means over column. Then the whole mean is subtracted from the template image which is the original image, and this whole data so this whole data is represented as image 3, which is an image subtracted mean. Now let's understand how do we correlate these both images. For this we calculate normalized crossed correlation coefficient. And how do we calculate this? For that I have first made an empty matrix named M for storing those all correlation coefficients, and then I have made a nested for loop and iterate over from ith row to jth column, that I is from 1 to r1 minus r2 plus 1, and the j is from 1 to c1 minus c2 plus 1. So now let's understand how do we do this. Let's consider target image, which is a image of containing more pixels, and then template image which is containing less pixels, and then we are moving that template image over target image, and we don't want our template image to go out of target image, so we made our constraint up to r1 minus r2 plus 1. What is r1? R1 is the size of that target image, and r2 is the template image. So we don't want our template to go out, so we subtract, we just iterate over that pixel value only, so that our template image just don't go out. So in the iteration, what I have done is I am calculating an image. And what is an image? An image is the target image that is overlapped by the template image in these iterations. Then I have updated this an image by subtracting its mean of the an image. And remember, what is an image? An image is the overlapped image by the template image in the target image. Then I am calculating here is covariance. Now how do I calculate covariance? Then covariance is actually, let's first understand what is covariance by x and y. Then covariance of x and y is x minus mean of x multiplied with y minus mean of y, and then for this function I am calculating mean of it. This is my covariance. And by this operation sum over sum, I have calculated this covariance of an image. An image is the overlapped image, of course, that I have updated here. And then this image i3 is the template minus mean of template, that I have shown here, that how do we calculate covariance. Now, as the name suggests, it is normalized cross correlation coefficient for calculating coefficient. So for normalizing, I am dividing it by square root of variance of image and then image 3. What is an image? An image is actually from target image over each iteration, and image 3 is actually the template coming from template image. And what is mi comma j? Mi comma j is storing the normalized covariance, that is normalized cross correlation coefficients, which is storing normalized cross correlation coefficient at pixel location I comma j in M. Now let's now for making or highlighting the particular area or the shape or something in the template image that I have matched in my target image. For that I have made another function plot box, and that function is dealing for making a square around the matched part of that target image. Okay. After this normalized cross correlation, let us understand why do we need partial cross correlation. As in normalized cross correlation, what are we doing? We are traversing over whole template so that it is not so efficient. So what are we doing here? We are just taking a part of template, that is partial template, and doing the same operation, and in this way we are reducing the time complexity of the operation. That is called partial elimination, means we are eliminating the template partially. So here we have made a function result partial cross co, and which is taking two input images, same as earlier. Same thing, it is first of all checking size. Size means it is checking whether it is RGB image or not for both images, and then what it is doing, deciding which is target and which is template image, and then storing size of both the images rows and columns, and then calculating correlation. But here correlation is calculated by partial. Let us understand how it is done. First of all, it is making empty M matrix, and then row theta th is equals to 0, means initially setting up threshold 0, and then traversing over image, so there is a two inbuilt for loops. And then for that particular template, what are we doing here is p is equals to 4 colon minus 1 to 1, means 4 to 1 decrease by minus 1. Means first of all it is taking 4, then 3, then 2, then 1. So what is the use of this P? I am dividing this R2, that is row of the template, and this is C2, this is column of the template, dividing it by P. Firstly it is divided by 4, that is I get 1/4 part of the template. Then secondly it is divided by 3, that is I am getting 1/3 part. Then secondly it is divided by 2, which is I am getting half template, and then it is 1, so I get whole template. So I have to decide up to what I have to go there, up to that level. So partial template, so I have read this template u1, u2 and v2 up to 1 to u2 and 1 to v2. This is my partial template, which the half or 1/3 or 1/4 template that I got. And then what I am doing is I am calculating whole the same operation that I did before in n cross co. This is the same. I am subtracting mean, then I am subtracting mean from both target image and template image, and doing convolution operation as same as before. Now after that what I am doing is partial row, means the convolution that I have to obtain the maximum value of that, I have to compare it with row threshold. If it is less than the particular row threshold, then I have to break. There is no use of doing further normalized cross correlation operation, because it became a monotonic function for me, and if I will do further this operation, there is no sense. How do I reduce complexity? So I will stop in between, and if it is greater, then I will continue doing that, and I will update the row threshold from the maximum threshold value that I have got, maximum partial row value that I have got. In this way I will reduce the time complexity, and this is the result plot box and plot box. So now let's see what is plot box is doing. What's plot box is doing? Same, it is also storing the size in rows form and column form, and then what it is okay, and then what it is doing is RNC. What is RNC? What is AM? AM containing the cross correlation coefficients of my target image, template image. AM containing that, and in AM maximum of AM, that is stored in RNC, which is saying R saying the number of the column R is saying the maximum values over each column in M, and C representing in that particular column what is the row number at which my maximum value is occurring. So in this way R and C getting their values, and then max of max over M is giving my maximum value over all M. That is I am again doing maximum, that is over all columns. It is giving me the maximum value. And what is C3 storing? C3 is storing column number of that location at which maximum value of M is stored. And then C of C3 is returning me row number of that M location at where my maximum correlation coefficient is stored. Then J3 is column number, and I3, as I said, is a row number where my maximum correlation coefficient is stored. And now I am simply copying the target image to result image, and for drawing the box around the matched part in the target image, I am writing this this whole part. This is just saying that how do we draw a square around that matched part. Then in main function I call this both functions, and able to draw the square around the target image. Let's have a look. So here, this is our template image, which is containing subpart of G and F, and then this is our target image, and while searching it founds the maximum correlation coefficient at starting point of this square box. So the plot box function draws a square around this part, and in this way we matched our template to target image, and we got our algorithm work. Thanks.